Okay. Can you stay with me in the session?
Yeah, I guess I'll just turn my camera off and let you have at it.
Sure.
Okay.
Super. Thanks. Okay, hello there. I'm gonna wait a couple minutes. I see more people are joining this session. Okay. Okay, everyone. I'm not so used to this webcast here, but I hope you can all hear me and you can see my screen. I admit this is a little bit confusing here. Let me see. Okay. Hi, Dale. I just see Dale send me a note here. Can you see my screen? That would be great to get some feedback. And can you hear me before I start?
So yeah, we can see your screen.
Yeah, it's sort of talking a little bit into the void, but it's okay. So I hope you're having a good event so far, and we have a session here to talk about this topic, which is called variants of uncertain significance. This sounds maybe very confusing, but I assume that you must know what that means. And so we're gonna go over this. And oh, thanks for the feedback there, Dale. And I will talk maybe 15 minutes or so, give you some overview, sort of from my point of view, what it is, why it's important, what can be done about it. And the best part is really, I hope, when you then we will have probably another 15 minutes to answer questions. All right, that's the plan. So let me tell you then what variants of uncertain significance actually are. So here are some potential conflicts of interest. So as you know, very well aware, CMT is not one disease, it's actually a number of different diseases. So your doctor may tell you you have a demyelinating or CMT type 1 or a X-linked or so on and so forth. So it's all under the umbrella of CMT. But and then of course we have these abbreviations. They can be confusing and very technical sounding, CMT1A, 2A, and so on. Now, when we go one level deeper even, then scientists, researchers have over the last 3 decades found that actually there is even a more variety of subtypes of CMT. And in fact, there are over 100 different genes now that can cause CMT. And you can imagine this makes the diagnosis more complicated. And of course, in the long run, it also probably makes the therapy more complicated. But each CMT patient eventually will fall into one of these categories. So each patient typically only has one gene that causes the CMT. So it really, in some ways, it's 100 different diseases. Now, what is a gene? What are we talking about here? Let me go back to the really basics. So as you may remember from school, or is that our body really consists actually of cells, a lot of cells, and they band together. They have very different specializations, and they make up who we are. And there are 40 trillion of those. Okay, a lot of cells. This goes from skin cells to blood cells to nerve cells. About 100 billion of them are nerve cells, actually. So in each cell is actually something called the nucleus. So it's kind of this darker spot in the middle of a cell. And in this nucleus, it's like a safe place where the genome is tucked away. Okay, the genome. And what is the genome? The genome is basically a storage device. It's a very long molecule that stores all the information, the key information to make your body and to fight disease and so on and so forth. And the genome is also what you give to your children. So the genome was a big mystery for a long time. It has actually 3 billion letters. Okay, it's a super long molecule, consists of 3 billion letters. And because that is too long, it's actually divided up in what we call chromosomes. Okay, so you see here the cell and the nucleus, and in this nucleus where the genome is are these chromosomes, and it's just a way to divvy up this very long 3 billion letter genome. And when you really sort of string it out, it's really literally kind of a very it's like a string, it's like a thread that you could pull out, and a small part, about 2% of that space on this thread are the genes. Okay, that's what we call genes. And genes really means this is where the key information lies to create proteins. Okay. Now you can imagine when you have a book with 3 billion letters of words in it, that when you copy this book, and that's basically what happens when we have children, every time this is being copied, there is a chance to make a mistake, right? That you read something wrong, and then the copy that happens has this mistake and carries it on, and the copy from that copy will also have this mutation. So we call these copies mutations, right? So they happen at some low rate, miraculously low rate, but they are there. So they are generally rare mutations, and they can be inherited. So they can be copied down to generations, and they also occur spontaneously. So not all the mutations you get or inherit from your parents, they also can occur spontaneously. Now, when they fall on a CMT gene, of course, there is the potential then that a person develops in their lives CMT. So that's really the relationship. These mutations in these genes, they can cause CMT. Now, over 100 CMT genes. The thing is this, not all the mutations or changes that are located in a CMT gene, not all of them cause CMT. There are sort of many that we call benign. They don't. And then there are the ones that really do cause it. And then there are many of them where we just can't say with certainty. So this is where the uncertain significance comes from. All right. So now you can imagine today when you get a modern gene test, there might be, in fact, 100 CMT genes on that test. And that's 100 genes with a lot of letters. And by chance alone, if you have multiple chapters from this book of life, many chapters, the chance that you have a spelling error, a mutation, is getting higher the more genes you look at. So in fact, virtually every person on this planet here has probably some mutation or some variation in a CMT gene, but only few individuals actually get CMT. And that is because most of these changes are benign. They don't do anything, all right? So the idea is that there are 3 different types of variations. And that is reflected in the testing results you get back from a genetic test. So one is when we call it's positive. It's actually not positive because a mutation was found in a gene that is thought to be pathogenic, that is thought to be causing CMT, causing the phenotype. All right. And then there is another testing result. It's called negative, which actually is positive because it means that no mutation was found in any of these CMT genes. Okay. And many patients, they end up with a negative result, which causes another problem because you want a diagnosis. So if there is no change there that is pathogenic, then you still don't have a diagnosis. And in fact, about 60% of patients receive in their reports so-called variants of uncertain significance. And these are changes where you can neither say they're pathogenic nor they are completely benign. And we probably can all imagine how this is a problematic result because it's kind of leaves everything in the air. It's very unsatisfying. It's unsatisfying for the patient, first of all, but also for the doctor, genetic counselor, and so on and so forth. So that's a big problem. So medicine is trying to address it, of course, but also trying to set really high standards of making sure we don't misdiagnose variants in patients. So one example is this quite extended rule set that the American Colleges of Medical Genetics, ACMG, has brought out, and most, if not all, of the clinical laboratories that run your tests and interpret your tests, they're using this rule set to determine, yes, this is pathogenic or this is benign. Another way so still, even if this rule set, a lot of VUSs occur. Another way is in our community of CMT researchers, we have created here in Miami, and this is being used worldwide, something called the Inherit Neuropathy Variant Browser. So what this really does, it's a website where everybody can go to and look at CMT genes, and we try to collect from patients worldwide their changes in CMT genes. So we collect changes in CMT genes, and we hope that over time there will be evidence because variants come from different places. And when you see, for instance, a variant not only once, but in another person, maybe from another country, and that person also has CMT, and maybe a third person, so then the confidence goes up to say, yes, this particular variant is not a VUS, this is really a pathogenic variant. So that is an ongoing effort and open-ended, really. Another national effort that goes way beyond CMT also is called ClinGen. So this is where geneticists and counselors and others come together, and we curate the evidence, the published evidence that a gene is in fact a CMT gene, first of all, and then secondarily, the variants reported, which of the variants reported are actually truly pathogenic and benign, and which ones remain VUSs. And so there is a CMT expert group tackling this problem. And we are working on this for the past 2 years, and this work will go on probably for another few years until we have gone through all the genes and variations. Another approach is to use computers, machine learning, artificial intelligence to better understand, maybe to better understand, which ones are VUSs really. So one example here is this Maverick software that we developed, and it's quite good. It's actually, we think it's probably the best that's out there currently to predict which variant in a CMT gene is pathogenic. And here's an example. This is a gene that causes CMT. It's called MPC. It's a well-known gene, quite common actually in CMT patients. And you see here how basically the red dots are known pathogenic variants that have been long agreed on. And in gray, you see the predictions of this software. And you can just see, roughly speaking, that the software agrees very much with the red dots. So whenever there's a red dot, the gray dot seems to be also high, and here low and low. And So you could extrapolate potentially that where you see only gray, there is no knowledge in medicine if those variants are pathogenic or not. So the software already predicts pathogenicity of variants that have never been observed in patients. So there is quite a good correlation here. And probably the best long-term solution is considered to use what we call functional assays. Unfortunately, most CMT genes don't have them available. Here's an example. ATP1A1 is a CMT gene that's fairly new. And when this was discovered, we were able to develop an assay in a petri dish in the lab where you can check a single mutation in this system in the lab. If it's different from this wild type, you see the wild type is a very high bar, and then you see these mutations here, they have much lower bars, and I think it's easy to see that there is a big difference here. And that actually indicates directly that this variant is pathogenic. So if we had assays for more genes and assays that can be scaled, so we can actually look at many different mutations, then over time we can actually truly say which one is VUS and which one is pathogenic. So, and just to summarize, these VUSs are a big problem. In some ways, they are threatening or spoiling the progress that has been made in genetics. Because when you test so many genes in one person, everyone has VUSs, okay, by chance, and that really makes it hard for everyone involved. What is the real diagnosis? And also with a VUS, with VUS you can't really be diagnosed. That's a fact. Also with a VUS, you will not be able to participate in a clinical trial for this particular gene, and you probably will not be able to receive treatment when it's available. And it looks like there will be treatments available in the midterm future for some, but not all CMT genes. And of course, it prevents or makes it harder to really effectively talk about family risk and family planning. So with this, I'm gonna stop here because I want to give us time to answer questions. Okay, I'm gonna stop sharing, and I assume you can just type in your questions here in the comment box. Okay, so Rojin is saying that that Athena did not find a gene for her. Athena is one of the clinical labs. She's from a larger family. Well, the question is sort of, should I retest? Or should I use another lab maybe that could give me better results? It's a little hard to recommend. The fact is, every single year, about 2 or 3 new CMT genes are being found, and every year, every other year, so these genetic panels in these labs like Athena, they grow. Right? They're ever growing. So if your test is maybe 5 years old and it was negative, I would probably consider a retest. The tests get better and better. But there is no hard rule to say, should I wait 5 years, 7 years, 1 year? 1 year is probably too short, to be honest. Another opportunity is maybe to enter a research study. Like we have a genetic research study on CMT. There you won't get a result back in a certain time frame, but typically when we find something, we would let patients know. Okay, another question from Lena. Okay. Yeah, so this type, I'm not too familiar with this type, this particular gene, SLC5A7. The best is really to go to one of the clinics of excellence, and the CMTA supports a number of clinics that you can find on their website. That's probably a good start. If you live far away from these, give them a call or contact CMTA if they have a better tip which clinic is good. And DHMN is a kind of a variant of CMT. So those clinics are well prepared to understand DHMN as a disease. I hope this helps. Okay, Rojan again. Yeah, Rojan, 5 years ago, why don't you leave a message? Maybe Ken or the CMTA can take your contact and they can be in contact with me. So we'll communicate. Okay, through the CMTA. If you're interested to join the research study.
So I have a question, Dr. Zuckner.
Yeah.
If somebody has CMT genetic testing done and the result comes back with several VUSs, or at least more than one VUSs,
Yes.
and a couple CMT genes, how do you go about trying to figure out which is the true culprit? Or are both possibly the true culprits?
Right. It's a significant problem, and there is no golden way out of this. The clinical labs typically do a very good job. They kind of follow the rules, right? And the rules are not there to make it harder. The rules are there to be safe, right? If you say this is a pathogenic change, as if a lab determines, that's a pretty big an impactful thing to say. So they follow these rules to make sure this is truly pathogenic or truly benign. Now, researchers have sometimes the freedom to think a little bit outside of the box, yes. However, that doesn't necessarily answer the question better, right? Because researchers do not take the sort of legal responsibility to say this is pathogenic. They may have an opinion, but and that's then the question: does it really help? So it's, as I said, there are multiple layers how we try to improve the situation, but there is no really great answer right now. Okay.
Thank you.
Yeah. So again, Margaret is asking if she can expect results from us. Typically, in a research study, we can't. We are not a clinical lab. We can't give any timelines. There are sometimes some projects where we push really hard, like the SWORD project, and some of you may have sent samples for the SWORD project because there is a clinical trial now ongoing. We try to return those results back, within 3 to 6 months or so. But again, we can't. It's hard, we can't really work on a timeline. We're not paid for that.
All right, I'm Dr. Zucker.
I understand this, Margaret. Debbie has a very specific variant. Yeah, I wouldn't know, Debbie. I would have to look at this if in more detail.
So Holly, I'm sorry. So Holly asked CMTZ and 4B2. What was the information in order to participate in giving and getting information on research? By Z, I'm going to assume maybe 2Z.
Where's this question, Ken?
That one is under the question and answer tab, up
Oh,
on top of the chat box.
there's another tab there. Okay. I'm not sure I understand the question, to be honest. How is the information in order to present giving? So typically the inherited neuropathy consortium, or what we do in Miami, we study many different types of CMT. We might have 2C. What is the gene, Holly? I'm not. See, I don't use this so much anymore because we are already at double letters. Do you know the gene name?
The gene for 2Z is the MORC2, MORC2.
Oh, okay. Yes. Also a fairly new CMT gene. If you already know this is, do you have a pathogenic variant in this? Who's working on MORC2? I'm not sure if this is one of the new ones, a few years old only.
Is that Dr. Antonellis up here in Michigan? I think I've seen.
I don't think so, but he works more on these tRNAs. Yeah, sorry. Definitely get in contact with the INC or the CMTA about it, and see if they have more information. So ad hoc is hard for me to give you a good answer. So Dale is asking if this is the 6601 natural history study. Yeah, so the this you're referring to the inherited neuropathy consortium or INC. You may want they have a website. We have a website. You can reach out there or go through CMTA, and then we'll see where this leads us. But again, if you have a VOS, I don't think we will have necessarily a better answer for you than a clinical lab, to be honest. And Lena, okay. Yeah, Lena, again, ad hoc, I can't say, right? To determine if a mutation is a VOS or pathogenic, that takes quite a bit of work to figure this out. So ad hoc, I wouldn't know, but you can assume your clinical lab did probably a reasonable job, a good job to do that. So maybe a retesting, as I said, after 5 years, that might be not a bad idea. The knowledge is growing every year. You have to understand. In some ways, this VOS topic, the hope is it will get better over time as we simply have more genetic data in general, and we have more experience with particular mutations.
So do VUSs get reclassified as benign mutations, or do we see they typically just get reclassified as a pathogenic?
So very good question, Ken. There are actually studies on this. Over time, if variants get reclassified, and I don't know what the numbers are for VOSs, but they do get reclassified over time. Not all of them, but there's always a portion a year later, 2 years later, that some of them now they considered benign or pathogenic. And even, believe it or not, sometimes pathogenic changes have been reclassified or benign changes, although that happens quite rarely, but it is potentially possible, right? This is science. We try to do the best in a certain time point. But there is VOSs over time, they will get classified in a definite fashion.
Thank you. There's a question from Karen over on the Q&A tab regarding an FFN2 variant.
Yeah. Karen, same here. I assume this was called VUS. Ad hoc, I couldn't tell you. I would also have to put work in it. Yeah, if it was a variant that was diagnosed and is a VUS maybe many years ago, it might be worthwhile to sort of reclassify to see if it has been reclassified now. But I couldn't say ad hoc.
And then
Yeah,
Debbie,
there's the question, right? Debbie is quick. Yeah, ultimately, if you really want a clinical diagnosis of this, which is the best, you probably would have to go through a clinical lab again. I'm afraid. They might have a better, since you already know the gene to look at. There might be a better price, better copay, whatever. But that is, even your genetic counselor would probably not do the reclassification. If you have access to a genetic counselor, I'm afraid you would have to go through a clinical lab again. If you really want a clinically proof report. Yeah. It's a bit like when you go to a doctor and he says, yeah, we need to do an X-ray or an MRI. And then the result is, well, it doesn't look bad, but there could be something, and we want to do another MRI in 2 years. We want to follow this. This is kind of how we have to look at these VOSs. You kind of want to follow them and hope that it clears up. So few people complain that they would get another MRI in a few years down the road, or a mammography, or whatever it is. And that's maybe it's a way to look at these VOSs and do a retesting after a certain time. I'd say 5 years is probably a good time frame.
and then Rachel's asking about checking source like ClinVar for your
Yes,
variant to see if there's been any updates.
yes. Now, absolutely, there are many great sources that everyone can access, but they are very technical in nature, and I wouldn't necessarily recommend it. As a lay person. But if you feel equipped to look at ClinVar and educate yourself, there is in some ways, there's no mystery about it, right? But if you want an expert opinion on paper, that's a different story.
And if anybody's wondering what ClinVar is, can you explain what ClinVar is?
Right. So ClinVar, you can actually Google it. It's a resource that the National Institutes of Health, the NIH, they provide this for free, and many large clinical laboratories enter they enter what their opinion is on certain variants in all kinds of genes, including CMT genes. And this is being published, and also in an effort to see how certain mutations or variants are being classified, because you will see in ClinVar there are quite a bit of one lab might say it's benign and the other says pathogenic. That you see this absolutely. And then also it collects all this data, and over time maybe you see, okay, 5 labs now have said this is pathogenic, and 1 lab still thinks this is a VUS. Then maybe it's reasonable to say, well, most labs think it's pathogenic, so it's probably pathogenic. So it's basically a website. You can find it via Google, and it's not the most user-friendly website, but it is doable if you feel up to it.
it's a bit cumbersome.
That's the one way to say it.
Yeah.
Yes, yes. Okay, there is something here in, let's see, Holly. But Debbie is asking, it would be nice if the reclassifications were published. Yes, I agree. Yes. These days, they might be published kind of online and not in a classical research study or paper, but ClinVer might do another data upload with reclassifications in it, and you wouldn't really hear about it or find it easily. But the experts, they would go there every day and they would see, oh, this has been reclassified. So it's probably less likely that this comes out as a paper, although it might. So a lot happens in the background and is just and appears on these websites. And these websites, to be sure, they are used by labs. So they use the same tools that you have access to.
And then Holly is asking, what does it mean when a variant occurs twice on the same chromosome?
Yeah. Okay. I'm trying to think what you mean by this. So you have we all have two copies of our genome, right? So two pairs of chromosomes, the same chromosome. So when there's a variant that occurs on one chromosome and then also on the other one on the copy, the same variant, that is what we call a recessive change. So you basically carry that variant twice, and if this happens in a recessive CMT gene, that can cause the CMT disease. I assume this is what you mean here. So this sounds to me like what we call in a technical terms a homozygous recessive change.
Yeah, that's how I read it. Possibly two mutations within the same gene.
Right.
Any more questions for Dr. Zuckner? I think they might be getting ready to wrap up. We're just past 5 o'clock.
Yeah. Well, it was a pleasure to help you with some information, and I hope you found it useful.
Thank you for your time. We greatly appreciate all the work that you do and all the time that you give. And if
Thanks
you
a
have
lot,
any
Ken.
questions that you didn't ask or you didn't get an answer to, please email info@cmta.us or cmtausa.org, and we'll make sure to get those questions answered for you.
Excellent. Thanks, Ken, for doing all of this.
All right. Thank you, Dr. Zuckner.
Yeah. Have a great evening.
All right. Thank you. You too.